Welcome back, everybody. I think as many of you know who use web browsers for web scraping, they're not really designed to be used well at scale, and it's quite a lot of work. So listen, I'm delighted to welcome Joel Griffith here from Browserless to tell us all about it.
Thank you so much. Hey. Thank you so much. Thanks, Site, so much for having us and provide. This has been an amazing conference. The amount of stuff that we've walked away from and learned, incredible. So yeah, as Shane said, I'm Joel. I'm the CEO of Browserless. We do headless browser stuff, more than just extraction, but extraction too. And so in this talk, I kind of want to break down, some challenges with headless browser automation, scaling stuff. And it kind of falls into three buckets. These are things that we've seen across the industry and from our users, and we sort of identified three patterns to make this more livable of a thing. So if the prior talks about legal and hallucinations didn't scare you, then I'm going to scare you further with this, but hopefully try to give you an escape hatch to get out of that. So before I get too much into that, I'm going to talk a little bit about who this is for. So this is primarily for engineers and folks looking to automate something. So this kind of supersedes the traditional web scraping case where you just want to get data off, but you want to do something on behalf of maybe somebody else, yourself, an end user who's given you, access to do this kind of a thing. This is also going to be helpful for managers, product managers, people that are thinking about this, or this is on the roadmap to come, and are just wanting to kind of know what they're getting themselves into. This is also for people who are really tired and just want to nap to somebody with a nice baritone voice. So if you're not technical, then you're probably in the wrong spot to a degree. So let's start with this. You want to automate a browser. You want to do something with the web. The web is a really chaotic place. It's funny to listen to all these talks and then hear about people talking about using a browser when you would want to, and it's always at the very end, unless you absolutely have to, don't. Wait until you absolutely have to. And this bullet point is really the reason why. It's, browser processes are expensive to spin up. They're slow to start. There's a lot of initialization they do if they're given a clean slate. And so there's just an upfront cost to even starting anything. Once they get going, it's a little bit of a different story. But, just that expense there is very difficult. Web applications are also growing more and more complex and complicated. Obviously, there's bot detection, things that make this even more nuanced and interesting. But the amount of JavaScript, all the frameworks, the CSS, Canvas, WebGL, you pool that all together, and the amount of responsibility we give web browsers is just growing ever more and more. So the other thing too, and this has kind of been sort of expressed in other people, and I kind of feel this way as well, is Chrome sort of operates, I'm going to speak mostly about Chrome just to kind of preface that, but Chrome operates almost on a per user basis, or per user basis. So, if you think about Google Chrome, it sort of operates on the assumption that it is for one individual potentially, or that's the core use case. So operationalizing Chrome to make it do something more than that is always a challenge. And yeah, again, we'll talk more about that. But I really apologize for these headlines. This was not part of the talk, but I wanted to just give an example of what this all means in practical sense. So if we kind of go down into DevTools here, we can look at the amount of resources that this CNN downloads and the time to finish, which is pushing 30 seconds. It's not great. This is on a fresh, no cache, nothing browser. That's really painful. It's really the World Wide Web, in my opinion. So, CNN in particular, it's many network calls that it makes to get to a state of renderability. There's third-party content, there's CSS. Lots of things are kind of needed to get a page to load. Actually, even just the definition of when is a page ready is always up for debate. Even Chrome's dev tool team, first contentful paint, first meaningful paint. So some websites won't be ready until images are there. Some websites won't be ready until Canvas elements are rendered. I could go on and on about this. But I think the big point here is, given this, how do we make this manageable and, operationalize it? So without further ado, here's, the three topics. We're going to talk about a cache. And so cache in this setting is Chrome has a file system cache called user data dir. We'll talk about that a little bit. This is where Chrome likes to dump everything that it can. Cookies get dumped in here, asset cache gets dumped into here, local storage, web SQL, all that stuff gets kind of persisted to the file system in this cache. It's nice because everything's there and it's ready to go, but the cost to that is that it's kind of like one user data dirt per one Chrome process. So if you wanted to like hydrate something for CN in particular, you have to think about like cloning that, and we will definitely get into that. Cookies. Cookies are a great way to do some speed ups with Chrome. It's not necessarily like a really fast speed up, but it'll get you like past potentially like a login step, or I'm in this zip code, or I'm a citizen of the EU and I need some sort of, handling with that. It's potentially good for bot checking. So if you get past a bot check, generally they give you a cookies, how most of these work. Once you have that cookie, you kind of have a hall pass to, run a little longer. It really depends on the nature of the bot technology at play there, but that can certainly help. And then obviously, user statesel and that, and that's kind of a cost of that. The last one, and the most novel, I think, of all of these is process. So in this context, it's keeping the browser process open, terminating whatever connection was to it, having it run sort of idly in the background, and then connecting back later. So, and this kind of sort of is a combinatory effect of all three. So the nice thing about this is it's kind of like a poor man's way to scale it. Like you can just have a process running in the background, reconnect later. You don't have to save stuff, and you just kind of have to handle sessions, like where should they go when they come in, when they reconnect. So let's talk about using the cache. Chrome's, like I said, saves stateful bits into user data dir. So on end user hardware, there is no flag for this. It varies on every operating system where this gets saved. Chrome has a lot of flags, so you can specify where you want this to be saved by user data dir, and this is where you'll see everywhere online, Stack Overflow, forums, things of that nature. When you start Chrome, you can specify this and point it to someplace in the local file system where Chrome is running to essentially hydrate where Chrome is at that point in time. Like I said, it's a dump of Chrome's application state. So, cookies, web SQL, anything and everything, is all saved in there. These are more or less one-to-one with a Chrome process has essentially one user data directory. This is kind of gone back and forth versions of Chrome where you could start two Chrome processes and point it to the same user data dir. Then you're getting kind of into indeterministic state, which is something that we kind of say not to do or be careful of. So watch out for doing that. Recently, Chrome has had trouble when you try to do two processes pointing to the same user data dir. So one-to-one is generally the way to go. So keeping one process to one Chrome user data dir is the best way to go. Otherwise, you need to sort of fork that folder. And what I mean by that, so this is copying that directory, making a duplicate of it, starting Chrome to point at that duplicate of it. And it's very, very costly. I want to stress this very much. The more that this goes on, the more Chrome runs and does stuff, that folder just keeps growing and growing. And I think a couple hundred megabytes is what we see, but we've seen 500 megabytes, and doesn't sound like a lot, but when you multiply it by 100 users, 1,000 users, then you kind of got a storage problem at that level. So what are good use cases for using a cache? When would this come into play? Dealing with SPAs, SPAs, single-site applications, things that persist to local storage, things that persist to a cookie. Anything that kind of is a single-page app is a good kind of candidate to start this with, just because everything again is saved in that, and it's a very poor but quick way to do it. It's also really great for a per user workload. So if you're doing something on behalf of a user, this is a good sort of analogous thing to do, is have that user's user data dir saved someplace. And the other thing I think this is really useful for is long-running or chatty workflows. So agents, AI agents, that's a hot topic. AI agents is a good one for this, because you can have an AI agent maybe start a browser process, do something with it, shut down the process. If I'm booking a flight, let's say, and say, hey, I'm interested in flights from Portland to Germany, and so it'll do that and find it, and then later on I can come back to that if you can point back to that same user data directory. So I'm going to give you like a really rough idea of what this looks like in code. I know this is a big Python crowd, and I'm going to show you some Node.js code, so please don't hurt me. So you'll start Chrome with a user data dir like this. So I'm just user bin with the user data dir. Once you're done with that, you can save this to like an S3 bucket or some other durable storage. I'm just going to copy it here for just kind of the sake of brevity versus having to like echo out all the lines you would have to have for moving that to S3. And then later on again at some point, download that user data dir, run Chrome with that, and you're back to where you were essentially as a quick way to get there. Yeah, so that's the cache. Let's talk about cookies a little bit. Cookies are great. If you know what cookies are, they're delicious. They come in a wide variety of flavors. There's chocolate chip, there's M&Ms, and the list goes on. Anyways, no. The cookies are a lot easier to work with because it's just a piece of stringified data. It's not a file system you have to deal with. It's not something you have to clone and replicate elsewhere or back up someplace, and then you've got data and rest problems. Cookies you can deal with on a much more sane level. You can take that, encode it if you need to, save it, and that way you're still GDPR compliant if things like that are what you're up against. It is not a cache, so it can work for certain things like remembering application state for a particular user, but it's not going to load local storage. It's not going to load CSS and JavaScript again. Like all those will have to be re-downloaded fresh again, so you won't get any kind of speed improvement when utilizing something like that. This is particularly useful for like maintaining just login state, and it's really easy to capture some preferences depending upon how the site works. So that's another kind of nice benefit. If you don't want to deal with files and folders, stringified data is just much easier to work out. Big warning on this topic, like when you're dealing, and honestly, to be honest, all of these other ideas, so like user data dir falls into this. When you're dealing with somebody's cookies, that's like, it almost should be PII in my opinion. It's the state of the world for that person on that given website. So, you're acting on like a God mode level here is what I like to call it. So be very careful with what you do with that and where you put it and how you put it and who has access to that. If you haven't done like a SOC 2 compliance, this will definitely come up. And obviously be diligent about how long you keep that around. It's it's somebody else's information that they've trusted you with. The nice bonus about this is you can potentially have multiple browser processes work on the same set of cookies and not have to consider like, is Chrome going to have a hard time with it? Obviously, every site is different. Some sites may not like seeing 2 users with the same cookies logged in. So just a heads up with that. It just varies like everything else we've learned today. So yeah, another rough implementation of cookies. This is like a Puppeteer example, but we've got getting the page cookies from the page you're on, and then just like a simple save cookies to a user ID, just as a brief sketch of what that would look like in code. And then conversely, when you come back later, we would load cookies for that user ID, and in Puppeteer, most other frameworks, libraries, same sort of thing. You can just apply those cookies and then go to the site that you expect those cookies to exhibit some sort of behavior on. So yeah, that's a pretty straightforward one. This is probably like the one that we've seen the most success with folks that kind of know the sites and web apps that they're automating against, just because it's really simple. Stringified data is amazing. You don't have to think a lot about file system management at that level. So, all right, this is probably my favorite one, is utilizing processes. So we call this in like browserless parlance, like reconnecting. And essentially you're kind of caching at the process level on an operating system. So this is probably the most straightforward, like implementation-wise to do, but it's the hardest to load balanced against, and that's because you could have many machines running many versions of Chrome. Each versions of those Chrome could be running many pages on behalf of many users. So if you were to like graph this all out, it would be just this big graph of like, where is this thing? So the challenge here is getting a load balancing technology to understand, like, given this URL that I want to reconnect back to, where is that in my massive pool of servers and Chrome instances running? So the sticky part is like definitely the tricky thing. So, and to kind of peel back the layers, for us at Browserless, we use a modified like Nginx with Lua to do this, so we can like parse through the requests, like look at it a little bit, and like understand where that machine lives, how to get to it, and all that. So this is actually probably the hardest part, is just getting a load balancer to kind of deal with that and understand it. The other thing too is a lot of libraries have this browser.close call. Anything with CDP, if you send browser.close, it actually kills the browser process underlying it. So not only do you have to deal with the load balancing part, you also have to intercept WebSocket messages and see what they're sending. And then when you see browser.close, know like, hey, I actually don't want to close the browser. I'm going to keep it open. I'm just going to send you a response back saying that I did close it, but it's still running under the hood. Everybody good so far? Take a breath. So again, very, very small example of how this kind of like functionally works in a program. We'll maybe get some content from a page. We'll grab the WebSocket endpoint from that page. This is more or less what I was describing earlier with close, is we want to call disconnect. We don't want to close the browser. We just want to sever our connection to it, but keep the process running. And then later grab that same URL up here and then apply it down later for like Puppeteer or whatever library you may want to be using there. So the challenges with this is that, like I said earlier, multi-instances is definitely difficult to do. You have to have a good technology layer with load balancing that understands all that and can manage that and forward it appropriately. TTLs and authentication are also another challenge. You'll need to roll some sort of authentication mechanism so like you don't get a collision of like, hey, this Reconnect call went to the wrong browser, because that would be like absolutely horrible to have that happen. And so having something monitor all those processes in the background, making sure they haven't been alive too long, or using too many resources. Yeah, it's like probably the trickiest part at Browserless is just like making sure that like no one Chrome instances is just hoarding too much and leaving nothing else to be able to be run. So, and again, I want to just really like echo the fact that like you got a lot of power here when you're doing stuff like this. So be careful if you're playing with fire. Just know what you're doing. All right, so the final bit of all of this is like, okay, which one do I choose? Which one's better? Had I had more time and thought about it, I probably would have built a nice like Plinko flow chart, so you could just tell it what you're doing and it would just tell you which process to go through. But here's a big slide with a lot of text that kind of goes over some of that. Happy to share slides with people if that's a thing that you want to do versus taking pictures. But this is kind of the rough like schematic that I kind of use for when to do it, and some pros and cons to it. Yeah, I feel like I've talked a lot about the pros and cons on all of these, so I'm not going to go terribly farther into that. But just to kind of highlight, cache, great for chatty, things that maybe need to come back and forth over a longer period of time. Let's say it's the span of days and you want to keep some sort of application state from Chrome around. That's probably the best time to use a cache. Cookies, again, for user logins that you want to persist maybe even longer than that, potentially days, weeks. That's a great strategy there. It's really easy to use and work with. And then finally the process one. This is probably the simplest to understand conceptually, and it doesn't really take a ton to like mentally model it in your head. But the challenges here are just, does your load balancing tech, whatever that is, support it? Is it gonna, not cross wires anywhere when you try to move things around too much? So, yeah, and vertical scaling I think is kind of a must in that scenario. So scaling is a whole nother topic on browser automation. So, yeah, I think that's a lot to throw at you this late in the day. And I know dinner is like sort of pending, and I don't want you to be too late to that. So I think we got a lot of time for some thoughtful questions, hopefully. Yeah, okay, cool. Happy to answer. Thanks.
Thanks. Do we have any questions from the floor? Yeah.
This is kind of a clarifying question. So on the process reconnect, that's essentially like somebody goes and logs in, does a couple actions, like let's just say this invisible person logs in and does a couple actions, and then like let's say hops off and they've just got like a session sitting there.
Yep.
Without it closed, and then you just come back and it's like they stepped back in front of the computer, essentially.
Yeah, exactly. Yeah, that's okay. Exactly how to think of it. Yeah, it's like a good metaphor would be, when you're at home, you walk away from your laptop, Chrome's already running, you come back, you log into your computer or whatever, and it's right where you left it.
Okay.
So same sort of thing, yeah.
Okay, can you give a practical example of how just anything, how this would be used, from a business perspective? Just maybe a most common use case.
Yeah, so one great use case. So if we went back to like CNN, that's actually a good example. Going back to CNN with a fresh browser, just so like maybe we're monitoring headlines to see what headlines are doing. If you keep a reconnect and reconnect back and then just do a quick page reload, it'll be much faster. There's no browser process startup time. There's no cache hydration. There's no asset downloading. There's no hot network calls. And especially if you're running in a data center too, that like charges you ingress and egress fees. It's really, really helpful for that, because then Chrome will just, hey, I've already got this in disk cache. I'm going to reload it from here. Some AI stuff has been really nice for that too. Again, for like flights is a good one. You'll have deals that maybe are temporary or 5 minutes or whatever. And so like kind of having that around and keeping that around is nice, just so it still is there when you come back to it. I think AI agents in particular is a really good one for like process reconnecting. So yeah.
Cool. Thanks.
Yeah. Hi. I just have a doubt on how you're utilizing user data directory. Like, assuming we are having sessions, right? So once the user steps away, there's some point of time where the session is gonna be expired, right?
Yep.
So how long do you keep that session alive until like, do you have a certain limit to which you like apply that?
I think in our code base, it's about 7 days, and we'll just go through and wipe out everything that's been there and hasn't been touched in a while. Honestly, of course, it depends, right? That's the theme of the day, it depends. It really depends on the site that you're at. If they have like a TTL on cookies, you might as well just keep that TTL for your user data directory as well. Anything like over a week starts to get into an area where it's like, well, what happens if it just keeps going longer and longer? Now you've got
it might become stale at some
exactly.
point.
It's stale, and then you're also possibly liable for having that data just sitting there somewhere. So but yeah, I think 7 days is just like a sane metric that we kind of started with, and that seems to have worked so far with it.
Thank you.
Yeah, great question.
And look, I assume this user data tier as well. It's each single user of your service gets a single user data tier, right? There's no sharing, and hence the sticky sessions and all that to route the traffic.
Yeah, sorry. Yes, you're correct. We don't. Yeah, it's forwarded to a new session. Some automation workflows, people will try to do that, and we like caution them like, hey, that's just like a really bad way to design this system and operate. So. But yeah, anytime somebody comes in and wants to like memorize a user data tier, we kind of just do that for them so we can apply best practices in the background.
Cool.
So just follow up question about the process caching approach. Like, so how long do you keep the process open? Like, do you have some TTL for a process as well? That's one question. And the other one is about the cost aspect of this, right? Because you have this process running somewhere, right? So it consumes your resources, right? So how do you manage the cost of that? And do you charge differently for this?
Yeah. So it depends on how much you're paying us. And then step one. No, I think the TTL for Reconnects is usually around 30 seconds. And if you are in a deployment model with us where we run discrete hardware for your particular account, we raise that up to, I think, a day, perhaps more. I don't think we've ever gone further than a week. Anyways, it's been a long time. It's still a window of some kind. We always like having a safety net somewhere, just regardless. The cost model is really good. So that's like a kind of like the know your customer approach is like, how much of this do you want to do? We kind of go through a nice right sizing thing to kind of like match your demand to infrastructure. And that way we can kind of understand and gauge like how much, CPU time do you need, GPUs, do you need memory, all that sort of thing. And then on like our shared cloud, it's definitely, we over provision the heck out of it just to make sure we have capacity to meet demand. We've done a little bit of work in auto scaling, but definitely need to do more there. There's been some interesting like auto vertical scaling solutions we've seen come into the market, which is interesting. And so we're going to take a look at that, because back to your point, like leaving Chrome running for a long time just means it's going to soak up RAM and soak up CPU time. And so you kind of have to be cognizant of that. So yeah, our open source image tries to actually monitor that too. After new sessions come in, it kind of does a quick pulse check. Hey, can we actually fulfill this? No, we'll reject it, and then it'll kind of be forwarded to the next machine for kind of like a simplistic example. So, yeah.
Just one more question, if I can, like about the load balancing part, right? So the load balancing has to be tricky here, right? Because the user request has to be routed to the same process later, right?
Yep.
So are you using out-of-the-box load balancers, or are you building your own custom solution for load balancing this?
Yeah, so we use OpenResty is the thing, and it's Nginx, but you can drop in Lua scripts to do some like programmatic like destructuring of the request and seeing like. So technically, we actually encode the underlying machine where it belongs to and a hash on the URL, and so we could just look at that URL and say, oh, this goes to this IP address. But yeah, I think that's an area that we're going to focus on, I think, next year and get like a better, like more hardened example or hardened technology for. So
yeah, that's great. And just final question, if I can, like the other areas, because like you mentioned cookies cache, but what about the local storage, SQL DB? There's so many other areas where the browser stores the data, right? Are you trying to manage that as well?
So that we kind of just dump into the user data dir bucket because all of that data resides there. And so once it's there, then it's just a matter of managing those, folders and like synchronizing them amongst machines. So yeah, but not directly. So yeah, cookies obviously like are most libraries seem to have a really good API around cookies, and like that experience is really nice. I think there needs to be further like done in the other ones like the SQL databases, local storage. So yeah, hoping that gets better, because then you can apply better practical examples there for sure.
Okay, thanks.
Thanks. All right, great questions, y'all.
Okay. Yeah, final question. So, have you tried making a warmed profile and copying only assets cache?
Yes, and it depends. It's like. It's really easy for the sites that you're up against, and so like, okay, if it's CNN and like Yahoo or Reddit or any of those, it's like, yeah, you can go visit those sites and sort of like pre-warm. We had a feature before where you could like pre-start browsers and then have them sitting idle waiting for requests. The problem is even when you just start a browser and literally give it nothing, it'll just slowly accumulate time and resources. Even though it's just sitting idle, it's just like, why is it going? So it's not something we recommend typically. We usually just like have it users split it out into two workloads. Like, hey, start something so we know it's hydrated, and then later you can come back to it knowing that it's kind of like more or less ready to go. Which is pretty simple, but yeah.
Makes sense. Thanks very much.
Thank you.
So I think we've heard today how retrieval augmented generation has been a really important use case in the last year for web data.